It's really a pleasure to be here. This is actually my first time in the Netherlands, and it's been, and in Amsterdam, of course, and it's been a lot of fun to avoid getting hit by a bicycle 3 times in 2 days. What I'm going to talk about today is conceptual. I'm going to give you lots of examples and some data, but really what I've been asked to do is to think about and talk about methodological challenges that I think arise in our current era. And our current era meaning an era in which we are suddenly, not quite suddenly, but in some respects, for some subfields certainly suddenly, awash in large-scale data. We have more data on more aspects of our lives as social scientists than we've ever had access to. And I'm going to argue that while doing so has rightly led to what's been called the data revolution in social science and improved the work of many scholars, including my own, in ways I'm going to show you, it has also led to some perils, the most important of which is what I call, in an essay I published this year, size-induced blindness, where the very massiveness of the data we have access to ironically blinds us to challenges in analyzing data that we as social scientists should know better. So to give us a context, as you know, I don't have to basically tell anybody in this room today, but we now have data on basically every aspect. Of course, economists and people in finance have always had access to large-scale data on banking, insurance-related issues, and people in transportation have always had, in varying degrees, access, to large-scale data on many aspects of transportation. But what's interesting is that many of us today have access to way more dimensions of the things that we had access to in the past. And in addition, we have access to things that we never had access to in the past, like consumption patterns and what people watch on Netflix by zip code, and where individuals travel based on their cell phones across a city. In short, what I think is interesting or powerful about data today is not so much that they're new. There have always been large-scale data, literally for millennia. What's interesting is that the data are now quick to access. They're digitized. You literally just download. You set up an API, you can get millions of data points in a week, sometimes in a day. They're comprehensive. They cover vast aspects of not just our consumption behavior, our financial transactions, but also our social interactions, our tastes, our cultural practices, religious practices, you name it, and also that they're inexpensive. What I'm going to talk about today is data that you can literally just get for free. You can follow people's movements across the entire country for free, sometimes for very minimal sums. I mean, the degree to which the data have become financially accessible, I think, are really extraordinary. I think it's really a powerful time. At the same time, there are some issues. And given that I don't think that the first set of points is controversial, I'm going to speak very briefly about the second issues. So I have to mention that what I think are the 2 twin problems or dilemmas for anybody, especially in sociology, doing analysis of a lot of the newly available data today, which are privacy and control. So privacy is, of course, it's wonderful that now you can track people's movements, and now you can look at what they post on Facebook or TikTok, Instagram. I'm trying to see what the right generation is. Napster, Venmo. No, people don't post on Venmo anymore. I think you get the point. Of course, it's wonderful, but of course, the loss of privacy is enormous, and we all know it. Yeah, it's wonderful to be able to track people's movements, to people's eye movements on their computers while they're browsing the web to see where their attention is focused, to look at the impact of social media content on user behavior. But again, you're tracking literally what people are looking at on the screen. So all of this is, of course, wonderful. The privacy issue is an issue. And then, of course, the control issue is important. Control is obviously, it's not just what's obvious, which is who gets to control your data. And we've already had lots of conversations about that. But it's also what happens to a social scientist when they're using data that are controlled by a private company. I think that one of the biggest things that we easily neglect that is important to our access to data today is that whereas 30 years ago, when you produced a survey to test a set of hypotheses, The data were being produced for the purpose of answering a set of scientific questions. But when Facebook makes its data accessible to social scientists, the data were produced for Facebook's purposes of making money, monetizing its engagement in one or another way. We're opportunistically exploiting those data for scientific purposes. And in that gap between data created for the purposes of conducting science and data created essentially for the purposes of making money, but used for social science purposes, lie many of the problems that I'm going to talk about today. But going back to privacy and control, I think one of the core issues, and again, this is just the bracket, we're going to talk about it, but we're going to get into methodological issues largely rather than ethical ones, the example I'm going to use is the idea that you could use Twitter, well now it's X, but it's really Twitter, at least as long as the company lasts, which is probably not going to be very long, to understand movement segregation. So as you heard earlier, this is an example from my own work. This is based on a paper that was published 6 years ago, which is literally an eternity in the context of data access. But at the time, in the literature on racial segregation in the United States, the majority of the work was based on where people live. So the study of racial segregation was by and large a study of the extent to which people of different races live in different neighborhoods. What Twitter at the time made possible was examining whether segregation on the basis of residence also translated into segregation on the basis of movement. So none of us spend all of our time in our neighborhoods. So if a city is very racially segregated by residents, but over the course of the day, people travel outside of their neighborhoods and come into contact with people from very different races, then the city is a lot less racially segregated than one in which people not only live in segregated neighborhoods, but also tend to stay within their neighborhoods. So to answer that question, you need to tap all the movements. Well, at the time, Twitter allowed people it was called Twitter at the time, to geotag their tweets. And for those of you who didn't know, I think that's interesting. Actually, the younger people probably don't use Twitter. You probably skipped ahead to TikTok or something. But Twitter is a social media app that at the time allowed you to opt in to geotagging all of your tweets. And geotagging a tweet means that when you post a tweet, the tweet automatically includes the location from which you tweeted it based on your cell phone location data. So what we did is we got access to millions of geotagged tweets, which we found ethical because you opted in, and then we anonymized the data anyway, and then we ran some studies. And we looked at residential segregation, and it turns out people maintain their degree of residential segregation when they move about the city in a much greater extent than we thought. But the data were fast, easy. We literally just downloaded the data. We had a computer just streaming the data for about 18 months. They covered the whole country, anybody who was on Twitter, and we paid $0 for the data. So running a large-scale survey of some 70 million people, for the US it was less than that, but call it 7 million people, in the United States would cost you millions upon millions upon millions of dollars. Downloading the Twitter data at the time was literally free. But the scary thing is what we could do with the data. And so here's an example. This is a map of the city of Boston. This is from Ryan Wang, my former postdoc, now tenured professor at Northeastern, was the lead author on this paper. This is an example of, from the Twitter data, what we could do in Boston. We just took one device. We looked at the tweets that happened between 8 p.m. and midnight, Monday through Friday, ran a simple clustering algorithm, and found the centroid of those tweets, and called that the person's home, a block group. We aggregated to the block group, and then we just followed the person. So here's one example of what we could do with the data. So you can see they live around here somewhere. This is in South Boston. They travel to downtown quite a bit. And this is the time period that we're capturing. Travel all over the city. They probably work right here near downtown. They left town a couple of times. They went to the north side a couple of times. Travel, travel, travel. So if you're not just a little bit scared, there's probably something wrong with you. And we could do this for every single device in our data. We believe we behave ethically. We didn't doubt anybody. But if you drill down, and we were looking at the block group level, but just imagine what happens if you just drill down into the places that people visited. We have the GPS coordinates. So we could see, for example, who was going to a gay bar on Thursday nights. We could see who was going to restaurants. We could see who we might have inferred based on the fact that they were going to church, Christian and married, but on the fact that they were going to a bar, maybe even doing things they weren't supposed to. The degree, and this is we thank the people, etc. The degree to which you could literally find out things about people that they might not want to is actually quite scary. So there are quite a bit of ethical issues at play that we need to take into account. But for now, I'm just going to bracket all of them. Not because they're not important, but because the other ones that are strictly methodological are, I believe, equally important. Meaning even in a world in which you manage to behave ethically and ensure everybody else behaves ethically and anonymize all of the data out there and so on, there are actually quite a few perils, and these derive from what I'm calling size-induced blindness. This term I coined to refer to the tendency to ignore basic limitations in a data set, limitations that are endemic to the origins of a data set. We're not talking about methodological problems writ large. We're talking about problems that derive from the fact that you're using data produced by another company for the purposes of making money or whatever for your own project as a result of its size. Right? We see the size, we miss it. And what I mean is this. This is a typical paper today in any general science journal and many of the social science journals. This is from a paper in Nature by a set of really good scholars, Raz Chetty, Matt Jackson, many of these people are friends of mine, etc. But this is a paper on social capital, classic social science question. Would have been difficult to address before, except through a survey of 10,000 people. If it was really big, 1,000 is more common instead. We have data on 21 billion friendships from Facebook. I mean, 21 billion, exactly. And they're not stupid. There's no coincidence that that's right there in the fifth line of the AISSR, because that's the impressive part. We see that, we say, holy crap, it's 21 billion people. Who could complain? Like they got it, right? And so the question is, in the context of that, well, why are you going to worry about a whole bunch of other things, given that you have 20 billion cases? What I'm arguing is that the fact that all our eyes went, 21 billion, is inducing a kind of blindness to very serious problems in our ability to answer important questions on the basis of the data. I'm going to talk about 4 problems and then stop, and then we're going to have a conversation. First, selection. That's the easiest and simplest. Second is what I'm going to call lampposting. Third, algorithmic confounding, and fourth, unobserved influence. Okay, selection. The problem here is simple. Large does not mean representative. And you would think that that's obvious, and yet you'd be surprised about the extent to which it's not. This is from data, this is from a paper by Foster. The book was published in 2021, so they only have data until 2020. But this is an assessment of the papers in economics journals, major economics, AER, Quality Journal of Economics, the American Economic Review, the Quality Journal of Economics, the Journal of Political Economy, and I don't remember what this one is. Sorry, I'm not an economist. Maybe somebody here knows. And so this is for papers looking at micro-level questions, the proportion of papers in each year that were based on survey data. And as you can see, I think this is QJE, it was something like 90% of them were based on survey data. Makes sense. You know, the US government, and probably in the Netherlands as well, spend millions on large-scale data sets like the NLSY, the National Longitudinal Survey of Youth, the Current Population Survey, etc. And as you can see, the low was about 40% of the papers. By 2010, the average was about 20% of the papers, replaced by versions of this. In fact, I'm sure that if they could follow the trend line by 2020, it's under 20%. It's just a trend. But here's the problem. The problem is that large doesn't mean representative. And I'm going to give you an example from a project we were going to do using Venmo data. So we were very interested in financial transactions. As you heard earlier, I got very interested in how people, the role of networks and how people use money. And I'm embarrassed to say that because I don't have a Venmo account, I didn't know about Venmo. But about 4 years ago, all of my postdocs and graduate students said, well, what about Venmo? I said, what's Venmo? Anyway, so they are all in Venmo. And so we thought, well, my goodness, let's go and get Venmo data. Because if we get, so Venmo, for those of you who don't know, is Venmo big in how many of you have a Venmo account? Ah, okay, beautiful. Ah, my people. So in the United States, all of you, if you were an American audience, just about all of you, if not every single last one of you, would have raised your hand. Venmo is an app that allows for the payment, the sending of money to anybody in your network on a pretty simple basis. So you connect through Facebook or whatever it is, and all of your network is now on Venmo, and you can Venmo cash to people. The reason it became so popular is because for people with roommates in the United States, Venmo became an easy way of cashlessly transferring their portion of the rent to the roommate. Also, for people going to dinner with their friends and sharing the bill, Venmo became an easy way to, on the spot, just send the 4 people at the table your portion of the bill, et cetera, et cetera, et cetera. So it became an extremely popular, extremely popular app. And now what's powerful about Venmo, or was, is that you could not only send money, but you could also send messages. So it's a social media app rather than just a money app. And in addition, originally, although this changed, Venmo, when somebody sent money to somebody else and said, hey, congratulations, or here's your donation, Venmo posted it publicly on the equivalent of the feed for other people to see. And so there was this, exactly, how could you, thank you. That's a right reaction. What? Yeah, this lasted for a while until people started getting worried about privacy. And so, for example, the idea was, if I start a charity or a donation campaign and I need money for a homeless individual I met, I would send the money, I would set it up, and then my friends would send the money, and then my other friends would see that my friend sent the money. Because, hey, Mario just donated $300 to, or $50 to blah, blah, blah campaign. And so this grew very quickly, and it became very powerful. They later started adding controls about who could see posts about what, and so on, based on the reactions that you had. And so Venmo, and there were millions upon millions of users, and therefore billions of transactions. So we thought, well, let's go and get Venmo. Well, we started looking into it, and there were privacy issues, of course, and the company got in trouble with it. But what's interesting is that Venmo, which if we had gotten access to the data, we would have been very tempted to use, is extremely popular among educated elites. But our interest was on financial transactions among people in low-income neighborhoods. And because Venmo was so big, we would have had very little trouble publishing papers based on the Venmo data. We know that there's tons of papers already, fewer now because of the restrictions they've added. But for our particular question, Cash App, and this is what I mentioned we learned, would have been far more useful. Cash App is like a Venmo, but it's much more commonly used by working class people. In fact, it developed earlier among tradespeople, plumbers and so on, so they could get cash on their small business. So you go, I go to your, I go to your company, I provide you with plumbing services, I want payment, I don't want cash, but you could use Cash App, which is like a Venmo, right? Send me money directly. But because Cash App was used by a very different segment of the population, it was not in the radars of the people like my graduate students and postdocs, all of whom were on Venmo for using these kinds of transactions. And so it would have been very, very easy to make the mistake of believing that because I have billions of transactions and millions of people, I don't have to worry about the fact that there's a fundamental problem with respect to who I'm reaching with the data. That's easy. That's the selection problem. That's the one we should, at a minimum, be asking, but we don't. A more serious one is what I'm calling lampposting. So this is the tendency to look for answers where the data are. So this is based on the, you probably have a version of this in the Netherlands, of a drunk at night by a lamppost saying, I lost my keys. And he's looking at the lamppost. Police officer says, wait, what happened? You lose your keys around here? He says, no, I lost them somewhere else, but this is where the light is. And so the tendency to look for answers only where you have light as opposed to where you should be looking for them. And this one is extremely pervasive. And it's so pervasive that I'm going to give you an example based on my own work. So this is a project on banking. Now, about 18 years ago, I was interested in resources in low-income neighborhoods and resources in minority neighborhoods. And among the resources I was interested in was banking resources. People had this idea that such neighborhoods were likely to be what are called banking deserts, places where you couldn't find a bank. And so I wanted to see, well, is it actually the case that access to banks is harder in low-income neighborhoods? That was my question. Is access to banks harder in in minority neighborhoods or in low-income neighborhoods? And so our approach in 2006 was pretty standard. This is literally, you can look it up. This is a paper I wrote with Monica McDermott. It was published in Social Forces in 2006. And so the idea was simple. Well, at the time, we have data from the Department of Commerce on all banking establishments and other kinds of establishments for every establishment in the country available at the zip code level. I thought it was fantastic. A zip code is not a great approximation of a neighborhood, but it's pretty close. And so if you want to understand whether there's access to banks in minority neighborhoods, get the zip code data from the Department of Commerce and see whether minority neighborhoods are more likely to not have no banks than other kinds of neighborhoods. And so the idea was something like this, right? So imagine this is a hypothetical city. It has 3 zip codes. Stars are banks. And so the idea is like, well, this is the place with no banks. And so the question is basically, are zip codes like zip code 1 more likely to be minority neighborhoods than zip codes like zip code 3? That's it. It's a very simple descriptive question, okay? So far, so good. Well, here's the problem. The zip code is just a designation created by the US government, the Postal Service, to distribute mail. It has no, literally, it's a classification method. That's it. It's not a social scientific designation. It has no bearing on whether we're trying to understand access in minority neighborhoods. It's just a convenient place where the light was. But I'll walk you through, and by the way, I've done a lot of field work in neighborhoods, which is what made this is going to come up earlier, but based on a lot of the field work I've done in neighborhoods, it was very clear pretty early on that even though that's where the data were, this was a terrible way to answer this question. And here's why. Now imagine that you're comparing, instead of neighborhoods, people, because at the end of the day, what you're interested in is whether people have access to neighborhoods. And imagine you're looking at 2 households, one here and one here. And imagine that you forget about the fact that the post office happened to divide neighborhoods into zip codes. And that's not just a city, forgetting this designation that happened to be a convenience because that's where the light was. Now, the first thing that you notice when you do this is that access to a bank is actually faster in the house that was into the supposed banking desert. Literally just closer. As the crow flies, it's just a shorter distance. First problem. But the second problem is that we don't fly like crows. We, walk, take public transit, etc. When we're trying to get from point A to point B, and all of the geographers here know this intuitively, we have to get on the bus or get on the train or follow the means of transit that affect how long it actually takes us to get somewhere. And in fact, if you conceive for a moment the process through which you access a bank, it is not so much whether a bank is in your zip code, it is how long it's going to take you to get there, regardless of where it's located. If I take all of you and I plop you in any random city in the United States right now, and you have no cash, and you don't have Venmo, and you need to go to a bank, you're going to pull out your phone, and you're not going to Google, what is my zip code, to then Google banks in my zip code. You're going to Google bank, and you're going to find the bank that takes the fewest minutes to get through. Access is really a question, from the perspective of lived experience, it's really a question of time. It's not a question of the geographic distribution of space as designated by an entity, the post office, that was trying to deliver mail efficiently. And so in this context, just to walk through the example, in order to get from this house to this bank, what you have to do is take the train, stop, take the bus, and cross over. In contrast, suppose this is an express train. You could take this train and go all the way down here, 2 zip codes away to the farthest zip code, and maybe even get there faster. In other words, the infrastructure of the city might affect access in light of time in ways that are more important to the original question, access to banking in minority neighborhoods, than the fact that I happen to conveniently get data from the bank, from the zip code, from the Department of Commerce at the zip code level. Now, what I like about this example is that it seems very contrived, doesn't it? Like, well, I'll take the train, take the bus, etc. It's actually not contrived at all. It's based on my field work. So this is a map of New York, the Upper Manhattan. So this is where I live right now. I'm a professor at Columbia University, which is based in New York. And the university is kind of right around here. This is Haarlem, a formerly Dutch neighborhood. This is Central Park. And so when you're looking at a zip code map, what you would do is something kind of like this. Except you of course, put the data in a spreadsheet and look at your data. But this is what actually the city looks like now. And I'm going to just give you a quick example of my own experience when I lived in New York. First, when I finished graduate school 20 years ago, I first lived in New York. And I moved to a place right here. And at around the time, this is going to be an example not about a bank, but about a supermarket, but it's the same idea. At around the time, Haarlem, you see all of this is Haarlem, was what was called a food desert, a place where you had a hard time finding food. Okay. But shortly before I moved there, a supermarket opened up right here. And the headlines, you can look this up yourself, was Haarlem is no longer a food desert. Literally, finally, you can get food there. In the 5 years I lived in this area of Haarlem, I went to the supermarket exactly 0 times. And here's why. So for those of you who don't know Haarlem that well, you see this thoroughfare right here with the yellow. The yellow are commercial buildings. That's 125th Street. That's the heart of Haarlem. If you know the Apollo Theater, that's on 125th Street. So that's like when you think of Haarlem, you're probably thinking of 125th Street. I lived right here first at 152nd, then at 142nd Street. In order to get to the supermarket, what I have to do is get on the A, B, C, or D train, take it south to 125th Street, get off, and wait for the crosstown bus to the supermarket. It would take an hour, door to door. In contrast, that same A or D train, so the A, B, C, and D train are 4 lines that go on 2 tracks. The A and D train are express trains. If I got on the A or the D train, I could come all the way down to Columbus Circle in about 17 minutes. I could get all the way down to Chinatown, the southern tip of an island, in about half an hour. So I actually did more of my grocery shopping in Chinatown than I did in my supposed no longer food desert neighborhood. The public infrastructure made an enormous difference to my ability to access what I was trying to get that would be impossible to capture with the zip code. In fact, I would literally have gotten the wrong story at the zip code level. Put differently, access was not a function of the zip code, it was a function of time. My scientific question was about access, but because the data were available originally at the zip code level, I distorted it into a question about access in zips. That's not the question, that's just where the light happened to be located. So what we did, by the way, we did better. In 2018, we just looked at every single block in all of the largest cities in the country, and we calculated the number of minutes it would take to walk or drive or take public transit from the middle of the block to the nearest bank. And then we understood access. Okay, so there's a solution, but that solution would have been impossible had I not gotten over the lampposting problem of reshaping my question, like the drunk, from where the keys are to where the light happens to be. And if you're interested, this is the paper. And just so you can see, just so that you know that I am not immune to the seductions of trying to embrace, here's the inevitable 6 million queries. You always have to have a million somewhere, or a billion, to publish a paper today. The third problem is algorithmic confounding. And this is, I borrowed the term from Matt Salganik in his book, Bit by Bit. And this is, but it's not just his, it's sort of out there. This is the idea that in platform-based research, and I'm going to speak specifically about research based on social media, behavior that you want to understand might be actually induced by the platform itself in such a way that you don't know whether what you're testing is social behavior or really platform behavior, and particularly algorithmically induced behavior. And here's what I mean. I'm going to use an example using large-scale Facebook data. And I'm going to use Facebook because it turns out more people are, believe it or not, more people are on Facebook than on anything else in terms of social media in the US with respect to social media. And so it's sort of an ideal case for some of the things I'm going to talk about. And it's still terrible, even though it's ideal. So there's a proposition in network analysis that's typically known as the transitivity principle, more generally the idea of triadic closure. And it's a very simple idea, which is that if you look at a network, the probability, so So if you and I are friends, and the two of you are friends, then there's a very high probability that the three of us, then I'm also going to be your friend, right? So that you can think of it as transitivity, or if you look at it in a non-directed graph, it's essentially triadic closure. That in a triad, the triad is going to, as long as there's two ties, it's going to tend towards a third tie. Put differently, this is the idea that people will want to be friends with their friends' friends. Okay? So that's a social behavioral proposition. It's not about social media. It's about what we do in the real world. We would have expected transitivity in 2000 BC. Now suppose we were going to say, aha, well in Facebook, I have 21 billion nodes. I can finally scientifically test this hypothesis instead of using those silly little 1,000-person samples. Well, you're going to face a couple problems. I'm going to set aside the first one, which is the friends problem, just to set it aside because that's not the important one, but it's an obvious one. So to give you this example, this morning what I did is I just went to my Facebook profile and I looked at friends. And so this is the number of friends I have in Facebook. And so a blind scientist who's not very good and who doesn't know Facebook would say, friends. Well, I can see the friends, and I can see Mario has 1,449 friends, and I can see whether there's triadic closure in the friends of Mario. Obviously, I don't have 14, well, this may not be obvious. I don't have 1,449 friends. I don't even think I have 449 friends. For those of you, those are not friends. Those are just what Facebook happens to call friends because it's trying to make money by calling them engagement. In fact, I don't know the majority of those people. In fact, this is from the site that picks the ones that Facebook thinks I know. And I won't say who, and I blocked out all the names to not embarrass them because some of these are sociologists, but I don't know all of the people in that picture. So if you're testing the sociological proposition that in a friendship network, people are going to exhibit triadic closure because they're going to want to be friends with their friends, you already have a problem in that Facebook friends are not friends. Facebook friends are ties of one or another kind, but they're not actually what we sociologically mean by friends. And that fundamental problem is there even if you have 21 billion Facebook friendships. Because you don't have 21 billion friendships. You have 21 billion something that people are doing. But let's take that problem aside. That's a huge problem. I mean, just think about it. I have acquaintances, I have people who are trying to reach me to sell me stuff, etc. So a lot of these are not my friends. Almost none of these are my friends, actually. Okay? But let's set that problem aside for the moment to get to the second, even more serious problem, which is algorithmic confounding. So as all of you, who here is on Facebook? Okay, I know, you don't have to admit it. I'll close my eyes. Everybody kind of has to be, but nobody really uses it. But here's the thing. The second problem is really more algorithmic induction, which is a serious problem. You've all seen this. And what is this? Remember, Facebook is trying to make money. And Facebook, by the way, happens to have a whole bunch of employees who took sociology classes just like mine. And in my sociology courses, what did they learn? They learned that people exhibit triadic closure in their networks. So all those computer scientists and programmers and whatever it was went out and said, well, of course, it's going to be the case that if I'm friends with you and if you're friends with you, I'm going to be friends with you. And so Facebook, somebody says, hey, you know what? I know what we ought to do is tell people how many friends they have in common. See where this is going? And so because they say, because of this sociological principle I learned in class or in my network analysis class or whatever, there's going to be likely to be a connection that you're going to want to make. Because Facebook wants as many of us to have as many friends as possible so we can have a greater probability of greater social media engagement. And you know this. So what the algorithm is doing is it's finding people that you're connected with and inducing triadic closure. Now here I come, I just download my 21 billion ties data, friendship node data, and I say, finally, I'm going to now test the sociological proposition dating back to Simmel in 1903 that there's going to be triadic closure in a network. And aha, perfect evidence. And now I have the real science showing, because I have 21 billion nodes, that what you've shown is that the algorithm believes in triadic closure and it's inducing it. You will almost certainly have way more triadic closure in Facebook than in a regular randomly sampled network of people in the street because Facebook is doing it on purpose. What's even worse is that you're going to wrongly, if you're not very careful, you're going to wrongly think that triadic closure doesn't just apply to friends. Because having your knowledge that Facebook friends aren't just friends, but also acquaintances, you're going to say, oh my goodness. And we also know that triadic closure applies to acquaintances and random family paper and people who only even work together and people who, by all means, may not even know each other at all. Look at the power of networks. It's really just algorithmic confounding. It's a huge problem that's very easy to get blinded to given the context of the data. Literally confirmation bias across the board. Final example. So I'm going to call unobserved influence. And this is basically a version of what everybody in network analysis knows as the boundary specification problem. Well, everybody should, but often kind of ignores it, which is the fact that when you're doing a network analysis of any kind, you have to arbitrarily draw a boundary around it. If you think about it, there's really only one social network in the world, and we're all in it, connected in one or another way, excluding maybe one or two truly isolated tribes in the Amazon with like 30, 40 people. No, it's true. I mean, that's an actual possible, they're possible, sort of that sub-network clique is probably isolated. Other than that, we're all connected. And so any network analysis that you get of all faculty and blah, 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 all professors in such and such, all members of the AISSR, et cetera, you're drawing an artificial boundary around it that you have to think about seriously whether it's justifiable. Very simple issue. But I want to walk you through an example of why this is so consequential. I'm going to use Facebook data again. This is for a typical kind of study that looks at tries to understand relations among students of different races using the entire University of California, Berkeley entering cohort of 2008, or all students enrolled in the University of California system in 2008, regardless of whether that's the entering cohort or whatever. There's many studies of this kind. And just to reconfirm why I think Facebook data is a good idea for this, it's as good as it's going to get. This is, you can just look at the left bar. The right bar is the same thing, but just for people who are under the poverty line. And this is across different generations. The proportion of people who use Facebook, Instagram, Twitter, now X, Snapchat, and LinkedIn. And as you can see, Facebook has the greatest prevalence across them. And yeah, millennials, which I guess, well, I don't know, some of you are millennials. Actually, I see baby boomers and, mid-career people and younger. But as you can see, Facebook has greater prevalence. So Facebook is pretty good for a question like this. The first problem is selection. That is not 100%. Okay? In other words, you're better off using Facebook than using Twitter and Snapchat, but you're still not getting everybody. So if you think you're getting the entire cohort of University of California, Berkeley students in 2008 or whatever, 2014, 2024, doesn't matter, you're only getting the people who happen to be on Facebook. And unless you think that race relations among students at Berkeley on Facebook are completely unaffected by the 30% of students who are not on Facebook but also on the same campus, you have a problem. And a serious problem. That's a perfect example of the boundary specification problem. But the second problem is there, even in the perfect world where every single human being were on Facebook, even if all of us are on Facebook, we all have interactions outside of the Facebook platform. In fact, we're all here right now. And those dynamics are affecting our relations, including whatever it is that we would do on Facebook. So if all of us were connected on Facebook, some of you would go on Facebook and write about it, and many of you would not. But on Facebook, as scientists would only get the wrong inference that our interactions with respect to everything we're talking about here right now are limited to whatever those few people who were engaged in Facebook did. That problem is across the board. Even if you have the entire community in the whole world, you're missing all of the people. You're missing all of the interactions by all of those people outside of that dynamic. Third, and now we go back to our example. Let's say you're doing a typical study where I got the entire, there's a famous paper like this in AJS. I got the entire cohort of the Harvard class of 2000 or whatever it was. And we can now finally understand in a scientific way, blah, 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 blah. Because they had all the students. Well, so you had all the students, you didn't have the faculty. In that same university, forgetting just like the people in the street, And the faculty, the behavior of the faculty in that institution also affect the relations among the students in the platform, even the Facebook limited relations. And so because you're missing parts of the network, and you're missing interactions outside of the network, and you're missing interactions by people who are not part of the network, outside of the network, all of your inferences about what's happening in the network have a huge sample selection bias problem. Not just the sample, but behavioral. Huge, huge bias problem. Complete bias problem. Almost nobody addresses this problem. And to make the point one more time, even if you have 21 billion people, you still have exactly the same problems. The size makes no difference to that problem. And that's the key. And that's an example of why everything I'm saying should be, in fact, it should literally be in Ego Network Analysis 101 is everything I just said. The boundary specification problem paper, that's from 1981, 89, somebody remembers? And yet, it's very easy. You don't see any reference to any of this in all of these papers. So these are 4 problems. There are many, many, many more. But the question is, well, so what do? You stop looking at large scale data? Well, of course you don't. Obviously, you have to be more careful. You have to be more theoretically sound, et cetera. But a big point that I'd like to make is that, ironically, even though large-scale data has obviated the needs in some respects for doing small-scale studies of some kinds, right? So if you have 10,000 people, 1 million people, 10 million people, 20 billion people, you don't need to, you would think, to look at 300 people. I think, in fact, the problems of the data science revolution have actually heightened the need for qualitative research. In other words, I don't think qualitative research is less important, and I also don't think it's as important as before. I think it's become more important because it's very difficult to understand the extent to which the problems I just described are a problem without doing the work. And so maybe to open up our discussion, what I'll leave you with, this is a graph from a paper I published in Nature Human Behavior a couple of years ago with Nicolita Rigoropoulos, my postdoc at Bremen, where we're looking at 3 domains in which there are clear roles for qualitative research to address some of the problems I've discussed. So on the data side, literally understanding the process through which the data that you are observing got produced. Everything from what the programmers were thinking through when they decided to recommend friendship ties on the basis of friendship ties to what is the process through which Twitter decided to allow or not allow people to geotag their tweets, and whether minors were excluded, or et cetera. On the interpretation side, being more careful about what you're actually finding. So in the context, for example, of algorithmic confounding, it's not just knowing whether what a friend on Facebook means, right? So I use the example on Facebook because we all know that a Facebook friend is not a real friend. But think about all of the data sets that we just download blindly from companies where there's a tag or a field with a name that seems intuitively what we're interested in, and we just don't have the experience because it's not something we normally use to understand what that means. That interpretive process requires you have to kind of talk to people. You have to talk to users, you have to talk to producers, you have to talk to exactly what the company believes they're generating with that. And of course, on the analysis side, everything from how you code your data to how much you should worry that you have a sample selection bias problem in a particular data set. I think it's also something that for which doing fieldwork is actually going to be important. And I have a whole, in the original talk, I had a whole bunch of examples that I can walk you through if you're interested. But the bottom line is the following. I do think we're in the midst of something quite unique historically for social sciences, and I think it's fantastic. I think it's extremely promising. I've exploited it myself. I think at the same time, as in any change, in the midst of the beautiful chaos of new opportunity, we can very easily become blinded to pretty serious challenges. I think the biggest danger, and a danger I already see, is the production of very beautiful papers that are scientifically wrong. Beautiful graphs, beautiful diagrams, beautiful plots, billions of X, amazing looking confidence intervals, but fundamental problems that are actually affecting the extent to which, rather than looking amazing, it's actually real science. So yeah, I actually do believe that in the midst of our data revolution, qualitative research is going to end up being more important to producing real science, not just to illustrating things, but to figuring out exactly what you think, whether what you think you're observing is in fact what you're observing. So I'll stop there. I write about this in these 2 papers, and I thank you for your time, and I'll now open it up.
Thanks, Mario, for this thought-provoking talk. I have a lot of questions, and I'm sure everyone here also, but we'll have a chance to talk with you over the drinks.
Yes.
And I will start maybe with a provocative question. So one might say that maybe we're not in the midst of data revolution anymore, because there are lots of criticism that big data is not so, it's dead, right? Big data is dead. I saw some headlines like that. But maybe we're entering AI revolution that would also transform the ways how we generate our data, how we analyze our data. What are your thoughts on this transition?
Yeah, that's a great question. So yeah, for sure. A different way of thinking about the question is that I've emphasized the fact that we have way more data than we did before. But I didn't emphasize that part of the reason we can analyze those data is because we also have way more computational power than we had before. Or the fact that in addition to that computational power, we also have new methods. And AI is essentially at the intersection of the latter 2 things, meaning given whatever data you have, we can now, well, I say we, a machine can now interpret a lot more of the data, a lot more data than we could, and make inferences on those bases, sometimes in ways that we would find difficult. So what I would say is the following. Number one, I don't think you notice I kind of stayed away from the term big data.
Yes.
Because it's catchy and it's not really useful, I actually don't think. The part of the issue is that size itself is not the problem. The problem is kind of what we're doing with the data that we have access to. I think the speed and comprehensiveness and ease of access are actually revolutionary. I still believe that. But I think the big data thing is kind of a fad, media-driven fad that we don't need to worry too much about. The second thing is I do think that AI is changing a lot of things for us as social scientists, and I am not sure yet all of the things that they're going to change. So here are some things that I can foresee and there's some things that I can't foresee. So with enough training, it's going to soon be possible to ask a machine to write code for you. In fact, it's already possible. I'm saying possible in a way that you believe it. To write code for you, to run regressions, to make predictions on the basis of whatever without you doing absolutely anything. And I'm not just talking about like unsupervised pattern finding. I'm talking about like, tell us, why, GPAs were higher among group A than group B, which is a backward-looking causal question. Or you could even things like, tell us, for what major economic issues is the effect of immigration bigger than we thought? Okay, and literally, this is not, you can easily foresee that that's going to be doable by a machine. I think there'll be even with that, there'll be some limits. One of the best and clearest limits has to do with a paper that just came out on PNAS recently that I reviewed and I wrote a comment on, which is not everything is predictable with the training data sets that we have. So many of you might be familiar with the Fragile Families Challenge. This is, actually Matt Selganek was involved, Sarah McClanahan and others. They had panel data on thousands of people followed over something like 20 years in the United States that were data on low-income families with the aim of trying to understand later achievement. And they ran a challenge where it was an open challenge, hundreds of teams participated, and the idea was, here's your training data set. They had a whole lot of data, and they gave everybody the same data, everything, every variable, all waves. And they said, your task with any team you want, using any methods you want, any data mining, any approach you want, you have all of the data, except the whole data set. Predict, I think there were 4 outcomes, but the one that comes to mind is GPA. Okay, that's it. Predict the GPA at X time period. They had, I think, 6 months or something. The very best models across all 4 outcomes didn't do better than accounting for something like 20% of the variation. They were awful. Everybody failed. And the question is why? One of the big implications from that paper, which goes back to, I think, some of the limits of AI, right? Because AI is essentially, bringing AI is essentially the equivalent of bringing a super powerful analytical tool to the challenge as an additional team and seeing what they do. I don't think that AI would have done any better than the teams from a group of people from all over the world who could have done whatever they want. And all this is, by the way, publicly available. You don't have to take my word for it. What they wrote is, it's a really beautiful paper. It just came out in PNAS, the most recent or the issue before that, on the limits of predictability. So here the task was prediction, literally just tell us, forecast the GPA. And so what they argue is your ability to predict any particular individual's GPA or whatever outcome is going to be a function of both errors in your model and also the degree to which that person's outcome is predictable given their observed characteristics from any model that you would produce. And because of that, at a minimum, because of that second thing, which AI can't touch, because AI can only do what it has based on the data it has access to, AI is not going to solve our problems. So that's one example. A second example is more on the qualitative side. So one of the things I'm very interested in is using in-depth interviews. Like, what can you learn? In sociology, we use interviews all the time to try to understand people's motives. I have a paper with Jenna Cook we published in SMR last year where we try to say, okay, let's look at all of the papers in the major journals in sociology and let's see how many used interview data, literally just talking to people to understand the motives behind their actions, the vast majority. Well, how do you know that you did it right? Like, how do you know that if I'm trying to understand your motive, if I pick any of you and I try to say, well, I want to understand your motives for being in this talk. Well, teacher made me, or it's super interesting, whatever, wanted to hear an American, whatever. How confident am I that by interviewing you the right way I can get at that? Okay. So you can think, okay, like a good interview is presumably over time we do that, and part of our paper was trying to develop methods for assessing whether the person did a good job. So in that context, if somebody reads our paper and studies all those methods, if they're good enough, they'll eventually get it. And so my question for AI is, well, is it possible that eventually, just like people are using AI for therapists and for social work, etc., it'll be the case that we won't need enough interviewers because a machine can interview people with enough training, effectively enough to do that well. And for some things, I'm already sure the answer is yes. In fact, I don't have any doubt that even within the next year, somebody could do this pretty well. But I'm only sure for those issues for which the answers we're going to get are within the domain of things that we already have data for. For things, and I'm not an AI expert, but for things for which in-depth interviews are really, really, really good, like discovering things you hadn't thought of because you spontaneously responded to something in the interview that made you change course on what you thought, right? So you can think of an open-ended interview as, I have my interview schedule with my 10 questions I want to ask everybody. AI can do that. But a good interview, in addition to those 10 questions, typically has more like 30 more questions because you tell me something I didn't expect and then I change direction. Mm-hmm. Moreover, having changed direction, then in the subsequent interview, I make sure to ask about this new thing I've started discovering and so on. I don't think AI will be able to do that as well yet, and maybe never. And if you think about it in light of the first paper I was mentioning, that's a little bit like, you know, the variability behind whatever mean you're observing that you just hadn't anticipated. And so I don't know. I don't think so. I think there's some things they'll be able to do, and I think there's some things for which there are limits. But both of those are separate from the data problem, and which is how I would think about this issue.
Yes, thank you. Returning back maybe to this issue of using data that has been gathered by different companies
Yes.
or governments, how do you think we as researchers can make sure that when we analyze this data, we don't perpetuate existing biases, because we don't know how they have been collected and they often have incorporated biases. So what shall we do as social scientists? How to use this data in a cautious way?
I love that question. And I think the first answer is figure out how the data were collected. And so I'll give you an example. This is on this project in finance. This is a beautiful example because it's so are you familiar with SafeGraph data? SafeGraph? Okay. SafeGraph is a company that tracks people on their cell phones, and a lot of researchers are using this data to track people's movements. It's a big company. It's one of the biggest doing this. And SafeGraph for many years made all their data for free available to researchers, because part of what they wanted is to have people like me write papers in serious journals so that they can then sell the data to private companies saying, look, they're good data. They were published in fancy journals. And so this example is going to be about the simplest thing SafeGraph does, which is classifying where people went. So from SafeGraph, you can find out exactly which store cell phones went to and how often, anonymized at the track level, over a period of years. So we were trying to understand how often people were going to banks as opposed to payday lenders. These are alternative financial institutions from different kinds of neighborhoods. Very simple, okay? And so for the first task we had to do was the very simple thing of saying, okay, here is what SafeGraph says is a bank, and here's what SafeGraph says is a payday lender. Is SafeGraph right? Is the bank a bank and is a payday lender a payday lender? Simple. In addition, SafeGraph says there's a bank here. Is there a bank here? Or was the bank, for example, already closed? I mean, this is about as basic. What I'm telling you sounds very simple. It's because it's exactly the very first question we wanted to know for sure. I'd already done enough that I was very skeptical of all of it. So we said, okay, we downloaded the 202,000 financial establishments that in early 2022, SafeGraph said existed in the United States. And we said, let's check. And we did multiple different kinds of checks. For part of the analysis, we randomly sampled 300 of them. And then we went to those neighborhoods, or we called those places by looking for them online, because you know the place, you know the address, etc. Moreover, we separately, we studied the product, right? We literally studied the classification. But then separately, we studied the process. We went into the archives, we called, there was one very kind person at SafeGraph who answered a lot of questions about exactly how they produce their data. We studied all their data memos, etc., and actually forced them to answer a whole bunch of questions they hadn't answered. And here's what we learned. Among other things, in part because SafeGraph's point is to make money, and you make money by showing that you have more data than other companies, and also by collecting those data with a machine, literally algorithmically, with as little effort as possible, in the process of generating the data, there's a built-in error. Maybe not anymore, because we published the paper. It just came out a couple of months ago in Social Science Computer Review. Mm-hmm. There's a built-in error that induces SafeGraph to wrongly think a whole bunch of banks or other establishments that are closed are still in fact open. I'm just going to walk you through this example so you know exactly what I'm talking about, why it's so important to really study the process of generating the data. Like, we have the power to do it. All we have to do is call the company. So the way SafeGraph works is they scrape data from a whole bunch of places. I'm going to use some examples, but this is not exactly it. So for example, Google and Yelp. So Google and Yelp both have data on the number of banks in Amsterdam and where they're located, okay? Now Google makes its money by giving you accurate data when you Google search for something, okay? Yelp makes its money, do you know Yelp? Okay, Yelp makes its money through engagement, right? So you write a review of an establishment, somebody comes in and says, oh, it's really funny or really informative, you get a whole bunch of stars, you like that, you keep writing reviews, etc. And so it becomes believable as a review site the more and more people engage. So that's how it makes its money. Now let's think through the process for a second. What happens when a bank closes? Well, if you're Google, you're like, oh, I better update my data and call it closed because I don't want people to Google my bank and then wrongly think it's open, because that's how I make my money. But now let's look how Yelp makes its money. What happens if a bank closes? Well, if a bank closes and 300 people have reviewed the bank, if I delete those 300 reviews because the bank is closed, I no longer have them. That's a lot less engagement in the site. So Yelp has an incentive to keep as many of those things, not wrongly call them open, but to keep as much of that engagement as possible. Now here's SafeGraph. I'm SafeGraph and I said, look, I'm the best. I'm going to scrape the Yelp data. Well, my computers are going to scrape the Yelp data and the Google data, and they're going to create a single database. And look, unlike Google, I know a whole bunch of other banks that Google didn't have. And then I'm going to go to company B and say, look, our database is so much stronger that we have a whole bunch of companies that crappy Google didn't have. That's exactly what happened. Something like 18% of the payday lenders in the data set were in fact closed, didn't exist. And payday lenders, for our study, 18% is enough to change the results of our regression. Absolutely, yes. We know this for a fact, especially because it's concentrated in low-income and minority neighborhoods, which is we were talking about this earlier, but this was the focus of our study. And so, yes, the first thing you do is you find out where the data came from. You have to make the phone calls. You know, I know making a phone call is kind of a radical thought for some of our younger, more social media raised, but you have to, there's just no other way around it. You have to do the qualitative research. There's no machine, no AI, no anything that's going to resolve this one for you because, of course, I mean, it was an algorithm. AI produced the data. It was an algorithmically produced data set. Of course, now they're better because they have our paper. Oh, well, not the paper itself, but we talked about them about these and other issues. That's just actually only one example. There are many other issues having to do with classification issues, about entities that provided multiple kinds of services. I mean, I can tell you the whole story. But the answer is, you investigated data. The regression can't investigate the process that generated data for you. You have to do that. And then separately, you find ways of assessing the data themselves. You randomly sample 300 or 500 or whatever it is, and then you just, again, do the field work. This is what, and I don't see any way around this. And moreover, if we had not done this, we would have had the wrong results, and nobody would have known, right? That's the key. That's why I'm like, I think it's actually quite important. We would not have known because the regressions look exactly the same, and the pictures are just as pretty. And unless you care as a scholar to find out, there's just no incentive out there. Nobody's going to look at the, I forget what it is. We have our millions of whatever. We always put the line in the abstract because people want to see it, but they're not going to see that and then say, well, I want to know whether the process through which SafeGraph generated it. No, they're just going to say, well, yeah, the SafeGraph data are great. And I think that's important.
Maybe last question.
Yes.
I would like to ask you, what do you think about the future of social media research? So you gave lots of examples from Facebook data, Twitter data, and it was such a luxury to use this data, but now it's very difficult to get access, right? I think a few years ago, Dan Freeland wrote about the post-API research crisis. Some people come up with data donations now. So what shall we do? Shall we continue studying social media, and how? Or you would suggest moving into maybe different directions?
Yeah. So I think we're going to have to study social media because so much of our lives are on social media. So to the extent, I'm a sociologist by training, to the extent that we care about social life, we're going to have to study it. We can't avoid it. So that's number one. So we'll have to. Number two, what I'll say is, yes, a lot of things are harder to get. So for example, Twitter no longer geotags tweets, so you literally can't write that paper anymore. Our SafeGraph data that we got for free are now no longer free. We have a paper coming out in a couple of months using the SafeGraph data to look at how much people are getting out beyond their comfort zone in their neighborhoods. And this is for PNAS, and you have to make a data disclosure thing, availability. And we did the standard thing, and then we went back and we realized we had to modify it because the data we use are no longer available. It's not just for free, but not even from SafeGraph. They're now available from another company that acquired SafeGraph, Advan. And so you'll be able to get our scripts, and you'll be able to run it, but you have to contact Advan yourself to get the data, right? So so a lot of what was easy is harder. But, so that's my second point. Even though that's the case, for any given data set that I would naturally expect to get harder, others are emerging that are getting easier to. So in other words, we're in a moving trajectory space. So just as we were getting out of using Twitter, we got SafeGraph data. And just as we were getting out of SafeGraph data, we were contacted by another company also trying to get into the data space that has access to a whole bunch of different data that they're going to give us for free for a limited period because they're going to want to sell it. I'm sure this is happening across the board. It was the same thing with dating sites. The dating sites for a while made data sets available, then they restricted them, but then other dating sites emerged that because they also want to monetize the engagement and therefore convince companies that the data are good, make the data freely available to researchers. And so part of what I would qualify that first statement is, as long as new social media companies keep emerging, I would expect new opportunities for a researcher. Just to be clear, I'm setting aside privacy and control, which you have to think about. But just in terms of data access, I would expect there to be still new opportunities because the space is still moving. For example, TikTok is in danger in the US. TikTok is, I think, the biggest younger one. So it's all at the cohort level. TikTok, I think, is the younger cohort. It's in danger in the US. I would not be surprised if they're forced to sell for real or to get out of the market. And if that happens, it's going to be almost no time before new entries come in. And Blue Sky already came in. Threads is only like a year old. And so I would expect actually more movement than just a closure. The second thing I'd say. The third thing I'd say is I think we still have a need for traditional methods. There was a reason the survey, like the last data revolution was the survey, the large-scale nationally representative survey. Social network analysis grew in part out of that. And right now, we still have the survey as a very powerful tool to understand social media engagement. You can run a survey and you can ask people to give you access to their social media, all of their sites, and you can follow them on all of their sites and see what they're doing inside and outside of the sites. So I guess the third thing I'd say is even though there's new opportunities emerging, just as we should keep doing fieldwork and talking to people, we should keep doing surveys. I think the surveys are absolutely essential to regain control of sciences of the data that we're producing. In a world in which we don't do surveys and we don't do fieldwork, all our work is going to be lamppost work. Because the light is only where the companies want the light to be, and the companies are trying to make money, not science. That's really it. And so I think we'll end up having to do surveys as well.
Thank you very much. I think we should stop. Thanks for this conversation.
Of course. Thank you very much.